Good morning, friends. Today I am going to discuss regarding digital communication assignment. First one, the difference between analog and digital communication system. First one, parameters, analog communication and digital communication. First, we start with definition. Analog communication is the technology which uses analog signal for the transmission of information. Coming to digital communication is the technology which uses digital signal for the transmission of information. Second point, noise and distortion. In analog communication system, it is get affected by noise. In digital communication, it is not affected by noise. Third point, error probability. Error probability is high due to parallax. Error probability is low in case of digital communication system. Hardware. In analog communication system, hardware is complicated and less flexible than digital system. In digital communication system, hardware is flexible and less complicated than analog system. Cost. Analog communication system is low cost, digital communication system high cost. Bandwidth requirement. In case of analog communication system, low bandwidth requirement. In case of digital communication, high bandwidth requirement. Next point, power requirement. High power is required in case of analog communication system. Low power is required in digital communication system. Portability. Less portability as the components are heavy. More portability due to compact equipments. Modulation used. Amplitude and angle modulation is used in analog communication system. In digital communication system, PCM, DPCM, etc. Representation of signals. Analog signal can be represented by sine wave. Digital signal is represented by a square wave. Signal values consisting of continuous values consist of discrete values. Example of analog signal. Analog signal comprises of voice, sound. Digital signals are used in computers. Second question is, what is sampling process? Sampling is defined as the process of measuring instantaneous values of continuous time signal in a discrete form. What is sampling process? Figure shows sampling process, continuous time signal. Second one, sampled signal. Sample is a piece of data taken from the whole data which is continuous in the time domain. When a source generates an analog signal, if it has to be digitized having ones and zeros, high or low, the signal has to be discretized time. The discretization of analog signal is called sampling. The following figure indicates a continuous time signal x of t and sampled signal x of t. When x of t is multiplied by periodic pulse train, the sampled signal x of t is obtained. What is quantization process? Third question. Quantization is the process of converting continuous range of values into a finite range of discrete values. This is a function of analog to digital converters, which create a series of digital values to represent the original analog signal. The quantization of analog signal is done by discretizing signal with a number of quantization levels. Quantization is representing the sampled values of the amplitude by a finite set of levels, which means converting continuous amplitude sample into a discrete time signal. The following figure shows how an analog signal gets quantized. The figure indicates the quantization. Both sampling and quantization result in the loss of information. The quality of quantizer output depends upon the number of quantization levels used. The discrete amplitudes of the quantizer output are called representation levels of reconstruction levels. The spacing between two adjacent representation levels is called quantum or step size. Mention the advantages and disadvantages of PCM. There are some important advantages of PCM. The PCM convenient for long distance communication. Second, it has higher transmitter efficiency, it has higher noise immunity. Disadvantages: PCM requires a large bandwidth as compared to analog system. Encoding and decoding and quantizing circuit of PCM is very complex. Write a note on compending process. Compending refers to a technique for compressing and then expanding or decompressing an analog or digital signal. It is a combination of the words compressing and expanding. This twin sequential process is non-linear but linear over short periods of time. Data is compressed before being transmitted. Compending refers to a technique for compressing and then expanding an analog or digital signal. It is a combination of the words compressing and expanding. That this twin sequential process is a non-linear overall but linear over short periods of time. Data compressed before being transmitted. Sixth question: what is the significance of ISI? In a telecommunication system, the inter-symbol interference ISI form of distortion of a signal in which one symbol interference with subsequent symbols. This is unwanted phenomenon as the previous symbols which similar effect as noise, thus making the communication less reliable. The spreading of the pulse beyond its allotted time interval causes it to interfere with neighboring pulses. ISI usually caused by multipath propagation or the inherent linear non-linear frequency response of a communication channel causing successive symbol to blur together. The presence of ISI in the system produces errors in the decision device at the receiver output. Therefore, the design of the transmitting and receiving filters, the objective is to minimize effects of ISI and thereby deliver the digital data to its destination with the smallest rate error possible. Seventh question: explain briefly about eye pattern. The eye diagram provides a powerful visualization tool to interpret behavior of the received waveform regardless of the pulse shape. The figure screencast video continues the discussion by the expanding the eye diagram plot on the upper right front panel of ISI and eye diagram. Follow along with the video matching front panel controls ISI and eye diagram to those of the video. The eye diagram reveals the important performance metrics for a communication link, including noise margin, ISI, timing sensitivity, and zero crossing filter. Figure screencast video to learn how to measure the performance and metrics, how to determine the optimum sampling time. Eighth question: write a note on FDMA. FDMA refers to the frequency division multiple access is one of the most common analog multiple access methods. The frequency band is divided into channels of equal bandwidth so that each conversation is carried on a different frequency. In FDMA method, Guardbands are used between the adjacent signal to spectra to minimize crosstalk between the channels. A specific frequency band is given to one person and it will received by identifying each of the frequency on the received end. It is often used in the first generation of analog mobile phone. Advantages: FDMA systems use low bit rates compared to average delay spread. First advantage: reduces bitrate information and use of efficient numerical codes increases the capacity. It reduces the cost and lowers the intersymbol interference. Equalization is not necessary. FDMA system can be easily implemented. Since the transmission is continuous, less number of bits are required for the synchronization and framing. Next question, compare BASK, BPSK and BFSK. Digital modulation, demodulation performance, error performance, advantages, disadvantages. BASK, easy demodulation, restricted in linear region, hardware implementations, simple and low, poor bandwidth. BFSK, matched filter detectors used, performs well, same as BASK, complex hardware design. BPSK, receiver circuit is complex,